Okay, hi. I'm Radek, developer advocate at QuickNote. And QuickNote is blockchain infrastructure. And if you are building anything on blockchain, you are doing yourself a disservice if you are not checking out QuickNote. So quicknote.com, look at it. And my talk is about what a good smart contract can look like, actually NFT smart contract. Because a very simple NFT contract is what we also saw for what Patrick Collins showed today. It's like maybe 30 lines of code. It's a very basic NFT smart code, and you can live with that. You don't need anything else. But if you want to start doing something a little bit more complicated, like if you want to start optimizing for gas, if you want to have some features like whitelist, or if you think more about the end users and about the listing fees or royalties or anything else, then a lot of more complicated stuff goes into play in terms of building your smart contract. And you can do it in a good way or you can do it in a bad way. The worst that can happen is that your smart contract is broken or is not safe, and everything is drained from your smart contract as you mint out. Or it can be ineffective in terms of gas savings, and it's expensive for people to mint, and they don't want to mint, or they want to trade, because that's also expensive. So there is a lot of ways how you can do it, and let's go through some. I don't know if you see the code. Hopefully you do. So this one, 7 minutes, that's fine. So first of all, readability and simplicity. So I'm analyzing a cryptocurrency smart contract code. They have built their contract in a very good way, but it took them a couple of tries. So this is actually like version 2 of their smart contract, because they started to mint out with version 1, and because there was an error in their smart contract after, I think, 250 or something like that mints, the contract broke and they could not mint anything else. So they had to relaunch the smart contract, and that's what happens if the contract is not good enough. So they actually built a much better version 2 of the smart contract, learning from their mistakes and launching something quite awesome. So this is for readability and simplicity, a lot of modifiers. Instead of building logic in each of your functions, you build nice modifiers that then you can apply very easily to each function that needs that, and we'll see more examples of that. So this is the minting function. And this is a more complicated minting function for the community sale, because that has more logic to it. So first of all, Merkle proof is how it handles whitelists. So it's actually a very elegant way to handle whitelists, very gas efficient. And at the moment when they introduced that, it was one of the first ones that was doing Merkle trees for minting out, for whitelists actually. Now a lot of contracts are using that, so that's the first interesting things. Then what it does, it checks how many, and you can see the modifiers like community sale active, can mint witches, is correct payment. So all of that were the modifiers that we saw in one of the previous screens. Otherwise, this function would be like 3-4 times longer. Now it's very readable, very understandable, also very easy to see if something is broken or not. So an elegant way to do things. Okay, so checks all of that, checks if you can mint more than you're allowed, and then mints. Then what happens here? So this is the faulty function on the left that broke the first contract. And it's about the gifting function. So again, as I said, you need if you need to do anything more complicated than just mint, you need to have good quality smart contract. And that was the one that broke. So the one in red. So what it did, you are allowed to gift witches to anybody, like the contract owners, because external only owner. Contract owners are allowed to gift witches to whoever they think, like the community members. And what happened is that as they were gifting witches, if they're also checking if their max witches per wallet was at the maximum, which you could have 3 maximum per wallet. So if someone was gifting, the owner was gifting a witch, and a wallet already had 3, it did not gift the witch, but increased the counter. So at that point, the counter of TS, which is total supply, the counter was incremented by 1. The gift was not, the witch was not gifted. Everything went fine with the gifting function, but then the next person who wanted to mint was using the total supply number, which was increased by 1, and they were also in that function, in the minting function, also increasing by 1. So at that point, someone wanted to mint an NFT, a witch, at the same ID that was already there, which was not possible. The function broke. There was no way to overcome it. The smart contract stopped. There was no way to do anything about it. They needed to relaunch. So this is how they fixed it. They broke it down into 2 different functions. One was a modifier, actually, which we saw previously, which does the job well. It checks if you can actually gift it, and then it doesn't just do total supply plus 1. It has a separate function for checking the actually increasing the next token. So that was one of the ways that was improved. Another one, and actually that's an interesting one. Again, I'm not showing it here, but when gifting, in version 2, they had another error that they were gifting at the same time as minting, but checking differently the counter of the gifted witches. So at some point, there were more witches gifted, and the counter of the total supply, again, was less than 10,000. So what they ended up having, that now they have like 9,750 witches or something like that, and that's the maximum that they can mint. Because again, of some logic in the minting function. This is the withdrawal function. So the first one is quite normal for every smart contract, but the other one is interesting, that you can also withdraw tokens from that smart contract, which usually doesn't happen. People don't usually send tokens to NFT smart contracts, and if someone does, then the owner cannot withdraw it. This allows it to do it. So thinking ahead of time, and this is also thinking ahead of time, and then thinking about the users, the end users. So it allowed for free gasless listings for the end user. So you don't need to approve the contract to list your witch. The contract does it for you. And if at any point this function is broken on OpenSea or on anywhere else, there's also another function that disables that. And that's, again, something that you don't usually see in smart contracts. It's thinking ahead, and there are multiple things in that smart contract. And royalties is another one. Usually, like on OpenSea, there is a default function for royalties. You don't even touch it. You just set it up in OpenSea. But this contract has a specific function and specific EIP for royalties, which is externally controlled. And wherever you are listing that on OpenSea or on any other marketplace, you can control that rather than having the default from OpenSea. And going quickly through. So what, just summarizing it here now, so what they did well, they went with ERC 721, which was an improvement over what was done at that point in time. It was like a year and a half ago. They went for readability, simplicity, gas savings, no listing fees, and also, yeah, coding for the future unknowns and thinking ahead what might happen and coding for that. Because yeah, for smart contracts, you cannot change what's already on the blockchain. What they could have done better, gifting witches, they had 2 tries, they still had 1 error. ERC 721A, it can be done better now, but it was not available at the point, so it's a little bit not fair to them to list that, but we now have that ability. And also what they could have done better, that to store the actual art on IPFS rather than on Amazon AWS that they have. And this is the summary. If you want to check more good smart contracts for you to have an inspiration on what you can do better, Azuki has a very good one. Goblin Town has a very creative one. You usually don't, creative and actually funny. When you read code, it's actually funny, so it doesn't happen very often, or almost never. So Goblin Town is also an interesting one. And a rule of thumb is that the newer contracts are actually much better because they learn from the mistakes, because they have more tools available. The original ones, like Apes, Punks, they're very, very, very simple contracts. It's not worth learning from them, but all the newer ones, the bigger newer ones are worth reading to and learning from. And that's it. Thank you.